Hi, I'm Akilan Prabhu, and statistical analysis can be really daunting, so we've made you this video to give you a place to start so you aren't clueless while you're venturing out into the unknown. We're going to be covering three main topics here: descriptive statistics, common variables and what they mean, as well as complex methods of analysis and how you can use them. Statistics are useful since they help give meaning to numbers. Whenever you have a quantitative set of data, statistics help you convey the conclusions that they suggest. Statistics are used practically everywhere, from computer science to the finance sector, and of course multidisciplinary research, making various different types of predictions. For the purposes of AP research, statistics are going to be useful when describing and analyzing the quantitative results of your study. This analysis will help form the basis of your study's conclusions, letting you reasonably predict how they apply to the population being studied. But before we can get into learning about more complex statistical processes, we have to be familiar with a few important terms. For this part of the video, using Google Sheets is probably going to be most convenient since we are covering descriptive statistics, and this is essentially a form of statistics that describes and summarizes a data set. So first off, you have the mean, which can be represented by these symbols. You have an x with a bar over it, or the Greek letter mu. And this is the average of a whole data set, and it's the central tendency of the set of numbers and gives you an idea of how the average respondent answered. When you have a set of numbers, to find the mean, you have to add them all up and divide them by the number of terms that there are. And when you're on Sheets, you can click on a cell and type in equal sign and in all capital letters, average, and open parentheses, and then you have to enter a range. So this is one cell to another, like A1 to A10. And you can find like the coordinates of a cell by looking at the row and the column. So that would be a letter and a number. And then you close the parentheses. You have the first cell, the beginning of your range, a colon, the second cell, which is the end of your range, and then close the parentheses. And then that will automatically give you the mean and the other types of descriptive statistics that we are going to be looking at. Next, we have the median, which is represented by an x with a tilde over it or a capital N. The median is the middle term of the data set. So if there are an even number of terms, you can average the middle two terms by adding them and dividing them by 2. This tells you what the 50th percentile is, serving a similar purpose as finding the average response, and it can be found on Google Sheets by typing in equals, a median, and then the range. Mode doesn't have a symbol associated with it, but can be abbreviated as MO. This is the data point that appears most often in a dataset, giving you the most common response, and that is, you can find that on Google Sheets by typing in equal sign mode. Next, you have range, which is represented by R. The value of the range can be found by subtracting the smallest term from the greatest term, and this gives you a rough understanding of how widely responses are dispersed. This can be found on Google Sheets by typing out equal sign max and then the range of your dataset minus min of your dataset. So there isn't really a function for range on Google Sheets, so you have to manually find the max and then subtract that from the minimum, and that just gives you the range. Next, you have standard deviation, which is a direct measure of how data points deviate from the median, and it is represented by lowercase sigma. It is, to find it on Google Sheets, you type in equal sign stdev with the data range. So that's all you need to know about descriptive statistics. And then we have inferential statistics, which is used to make predictions about the population being studied. However, this isn't something that's easily calculable, and you won't be able to use Google Sheets for it. So you want to use an external online calculator or Excel, which we'll cover shortly. So our first variable in inferential statistics is R, which is the correlation coefficient. When you're doing linear regression and have a line of best fit, R is used to evaluate how strongly two variables correlate with each other. R is between -1 and 1, where 1 indicates a positive correlation between two values, meaning that if one variable increases, the other also increases, while -1 indicates a negative correlation, so if one increases, the other decreases. An R value of 0 means that there is no linear correlation between the variables. Next, we have R squared, which measures how well the line of best fit models the data. It values between 0 and 1, where 0 means that the line of best fit does not model the data at all, while 1 means it models it perfectly. You want to be closer to 1, but it depends on what your study is. Next, you have p-value, otherwise known as the probability value, represented by the letter p. And this tells you how likely it is for the null hypothesis to be true. The null hypothesis states that there is no relationship between the variables being studied. If you have a low p-value, which is less than 0.05 typically, you can state that the alternate hypothesis, that there is a relationship between the variables, is true. The alpha value is represented by the Greek letter alpha, and is the threshold at which we consider results significant or not. And it is typically set at 0.05, which is where the previous 0.05 figure comes from. It has to be less than that value for the null hypothesis to be rejected, which makes the results significant. Now let's go through a few questions to make sure that you completely understand. So, given the following data set, find the mean, median, and mode. So I'll pause for a second. If you need to, pause the video and come back. Okay, we will start solving now. So to find, first rearrange the numbers so that they're in order from least to greatest. So that would give us 2, 3, 5, 6, 6, and 8. To find the mean, get to add up all the data points and divide them by the number of data points that we have. So the sum of these numbers is 30, and there are 6 numbers, and 30 divided by 6 is 5, which is our mean. The median is the middle value of the data set. So we have an even number of data points here, so our middle two values are 5 and 6. And if we average those, that is 5.5. The mode is the number that appears most often, and in this case, it is 6. How'd you do? Once you're comfortable with this, you can answer a few questions about inferential statistics.
Now that you know about descriptive statistics and some of the most important variables you will use throughout your analysis process, let's look at some methods of analysis that you can apply to your study. First, we'll look at a useful tool in correlational analysis, linear regression. This method allows us to measure the strength of a relationship between an independent and a dependent variable. While other methods use a more powerful Microsoft Excel, the user-friendly Google Sheets is more effective for linear regression. In this case, we'll be looking at the relationship between the ratio between sleep and stress, as expressed in column T, and screen time values, in column C. The first step is to go over to Insert and insert a chart into your Google Sheet. This is already pre-filled in. So what we'll do is delete the 2 data ranges here. You may not have these data ranges, and that's okay. And just to clear the sheet. So now we have a blank sheet, and what you'd want to do is select scatter chart, which was already filled in due to previous data analysis. And so what we're going to do is enter in the data ranges that we'll be looking at. So there's 2 data ranges that we'll be serving, which are screen time and sleep stress ratio. So what we can do is click on column C, add, and click on column D, and as you can see, they're filled in. And so now we have the 2 data ranges. And what we can do is, since we want to see the effect that screen time has on the sleep stress relationship, what we can do is, to the x-axis, we add screen time, and to series, which is the y-axis in this case, we add the sleep stress relationship. So in this case, we now have our scatter plot. And this displays all of the data points created with the x-coordinate in C and the y-coordinate in D. And what we can do with this information is, if we go over to Customize and Series, you'll want to scroll down until you find a trend line. This will generate a line of best fit, which is a line that maps out, well, that tries to map out the points in the dataset. And so in this case, you'll want to scroll down to Label and click Use Equation. And so what we can see here is that the equation for the correlation in this case is has a slope of negative 2.99 times 10 to the negative 3. This is an extremely low value for slope, very close to 0, which shows that the correlation between the sleep stress relationship and screen time values is minimal. What we can also do is we can click the button Use R squared here, defined an R squared value as explained earlier by Akilan. And so in this case, you can see that the R squared value of this correlation is 0.038, which is extremely low, and as the more statistically significant R squared values would be closer to 1. So in this case, you can see that the correlation is minimal between screen time and the sleep stress relationship. For the next portion of this tutorial, we will be using Microsoft Excel. In order to do this, you'll need to install the Data Analysis Tool Pack or add-in to your Microsoft Excel. You can Google this throughout, as there are many tutorials online for how to install this, since it is used in most data analysis through Excel. Next, we'll be looking at multivariable regression, which is useful for calculations with more than one variable. This form of regression determines the impact of several independent variables on one dependent variable. In this case, the dependent variable is stress, while the independent variables are screen time and sleep. And so in order to calculate this regression, what we're going to want to do is first go to Data, and over here, under the Analysis tab, you'll see Data Analysis. Now you'll scroll down to Regression in this case, and you'll want to input your ranges for Y and X. So these were already pre-input for me, but you'll have to input these yourself. And so what you'll have to do is, in terms of the Y range, for me, my data goes from C1 to C53 for stress, which is the dependent variable, which means that'll be the range that I input in. And you can see that it automatically did the same for A1 to B153, which is the total range of all the independent variables. You want to click the Labels button and the Confidence Level button. Labels tells the computer that the cells A1, B1, and C1 aren't being considered in this calculation, and the confidence level lets more statistical calculations be done. And so I'll create a new workbook and I'll name it regression analysis here. And I recommend experimenting with as many of these different residuals and probability plots as possible, as you'll never know what you might be able to use in your paper as effective statistical method of analysis. It honestly depends a lot on your study. So click the OK button and it'll generate our new sheet. And so the most important things you'll see over here are in this table from A16 to I19. So first of all, what you'll see here is coefficients, and a t-stat, and p-value, which are your most important things from this. So in terms of coefficients, you can see that this coefficient of 30.88 here. This is the computer's attempt to create a linear line of best fit for the data that was provided, which can be seen here. These are centric values, but this cannot be taken verbatim. What you have to do is consult the p-value and the t-statistic. So p-value, which you've learned about, as you can see in this case, for this, the p-value is extremely low. It's very close to 0, which suggests a statistically significant relationship. In this case, the p-value is 0.07, well, 0.08. So in this case, and in the case below with 0.9, which is an extremely high p-value, these two would not be statistically significant values, although this would be close. And to look at the t-stat, what we need to do is to consider the t-critical, which needs us to perform a different calculation. So what we'll do is in this cell, we can write in the function t.inv.2t, which will give us the critical value. T dot. So you can press tab to autocomplete the function. And what it's asking for here is the probability and the degrees of freedom. So in this case, the probability would be due to our desired standard of error of 95%, 0.95. And degrees of freedom, or DF, can be found over here. In this case, the overall, the total degrees of freedom are 151. So we'll put that in. And as you can see, we received the value of 0.062. Yeah, so in the case of this t-statistic, you can see that the absolute value of the t-statistic for the intercept, which is the t-statistic for the intercept, does exceed the critical value, which adds to the statistical significance of this table and the data gained by this regression analysis. Furthermore, over here, you can find the r-squared values outputted by this dataset. So this r-squared corresponds to these coefficients and the attempt from the computer to generate a line of best fit. So as you can see, since the r-squared is very low, the actual variance indicated by this, the variance predicted by this line of best fit is very low. Now we'll be looking at a more complex method of analysis, two-factor ANOVA. ANOVA stands for analysis of variance, and it can help the researcher measure a relationship between independent and dependent quantitative variables. Specifically, it allows for a greater insight into the proving or disproving of the null hypothesis. So in this case, we'll be conducting two-factor ANOVA on the variables of screen time, sleep, and stress. So what we're going to want to do first is go over to data, which is already having, and then data analysis. In this case, we're going to want to scroll to the top and click ANOVA two-factor without replication. And so again, the range is autofilled here, but what you would want to do is take the ranges of all of your data with your y values, the dependent variables at the end. In this case, it's already formatted like this. And what we'll do is take all variables from A1 to, at the bottom here, I scrolled a bit too far, C153. So we'll put in A1 to C153. Again, click labels so that it doesn't get confused by the text in A1, B1, and C1. Choose an alpha of 0.05, which is the scientific standard. And we'll create a new worksheet over here. So, okay. Now what you'll want to do is scroll down to the very bottom, and over here you'll see the ANOVA analysis. I'll make these a bit bigger so that you can see it a bit more easily. And so in this case, what happens is the rows will correspond to sleep, and the columns will correspond to screen time. And what this is doing is looking at their effect on stress. So rows correspond to sleep because sleep was in column B in this case, and screen time was in column A, which is why is in columns. And so in this case, the three statistics that we'll want to look at closely are F, p-value, and F crit. So first of all, the F statistics looks at the variance in between groups, and it's a measure of statistical significance. So what we can do is, if the absolute value, in this case, these are positive, but if the absolute value of the F statistic is greater than the F critical statistic, that's an indication of statistical significance. In this case, for sleep and its relationship with stress. This is not the case. However, it is definitely the case for screen time and stress, as this is 4,000s and this is 4. Additionally, what we need to do is look at the p-value significance. The p-value is about 0.57 here, which is a lot higher than the 0.05 needed for statistical significance according to the general rules used in most studies that you'll find. However, in this case, the p-value for the screen time and stress relationship is extremely low, to the point where it's very statistically significant in this case. And so this helps us rule out the null hypothesis for a relationship between screen time and stress, but it also helps us say that the null hypothesis is true for the correlation between sleep and stress. More statistical analysis is needed in the form of something like a line of best fit to look at specific correlations in this case, but this also helps us come to conclusions about the reliability of our data. So here are some possible issues or problems you may run into, and some general tips and advice. So first of all, there's a good chance that you may find that your null hypothesis is true, or that there's no correlation in your data set. You can still have a great research paper without having that statistical correlation. The only issue that arises from this is it is sometimes more difficult to come to a conclusion. And what you can do, which helps with this, is tie that conclusion more heavily into your future directions. So, for example, in my study, there was no correlation between screen time and the sleep-stress relationship. And so I came to the conclusion that there was no general level of screen time that dictated a stress level or a sleep level. Instead, what I said was that a tailored approach to screen time would be more effective in dealing with the ramifications of high levels of screen time and high stress levels than a general approach. While this was very specific to my study, it's an example of what you can do to get around a lack of a correlation or null hypothesis. Furthermore, another common phenomenon that happens during data analysis is when you get stuck. You try multiple different methods of data analysis, and nothing seems to be working. And you can't find any correlations in your data. While you can accept this and move on, and if you've tried everything, you're still going to be fine, one tip that I have for you is to stay persistent. You often have to continue to fight with the data to come to conclusions. What this means is continue trying more different methods of statistical analysis. Do your own research using many methods, such as Google, YouTube, and ChatGPT with acceptable use, as outlined in the AV Research Guidelines. And all of these methods can help you eventually come to more effective conclusions. For example, you might not find that your overall hypothesis is true or confirmed, but you may find that a small part of it, or a different relationship between multiple things that you're looking at, is true. And that is data that you can use to great effect in your paper. Now, try your hand at 2 questions to see how much you learned. Number 1, what is the difference between R and R squared? I'll give you a second to think about it. Well, while R measures the strength of the association between two variables directly, R squared, which is known as the coefficient of determination, shows the proportion of the variation, so the proportion of the difference from the line of best fit, in that dependent variable, which is predictable from the independent variable. So it's a measure of how accurate the line of best fit is. And now I'll give you another question. What is the main difference between the p-value and the alpha value? So the alpha value is associated with the confidence level, and it tells us how extreme results must be for us to reject the null hypothesis. The p-value, on the other hand, is a probability that a statistic occurred by chance alone. It's not related with the confidence interval. However, the p-value and alpha value are related, as if the p-value is less than the alpha value, you can say that the null hypothesis is true. Let's go over what you learned today. First, you learned about the uses of statistics in AP research. Next, you learned about descriptive statistics and their uses. Then, we learned about many important variables that are commonly used in statistical analysis. Finally, you learn multiple methods of statistical analysis and the merits of tools such as Excel and Google Sheets.
Now you know enough to get started working with statistics, but depending on what your study is, you might want to find more in-depth explanations for clarity or look into statistical tests that we did not cover from another source. On AP Classroom, the 3-video series titled Statistical Analysis is really useful if you want to refresh yourself on how statistical analysis generally works, going over topics like what a null hypothesis is and how you would use it for the purposes of AP research. The chapter in your practical research book on qualitative research has really good information on what p-values mean in case you need clarification there, as well as other similar tests involving the f-value and t-value, new variables that give you other checks to disprove the null hypothesis. And finally, the Handbook of Biological Statistics, which is the link provided here, is another great resource you can use for in-depth explanations of all sorts of statistical tests, including some that we have not covered. It also includes variations of tests that we have covered that might be better suited for your specific study. Okay, that's all we have for today, and good luck writing your papers.